ladies and gentlemen. Welcome to part one of an 8-part series called Let's Get Ready for the PSSAs with Mr. Parrish. I'm in my man cave. You will hear my children screaming in the background, but no matter, we're going to have fun anyway. So part one is the number system. We're going to talk about the number system, talk about square roots, irrational numbers, rational numbers, stuff like that. So let's talk about the primary names of stuff in the number system. Real numbers are basically any non-imaginary number. Okay, and if you're like, what's a non-imaginary number? Well, if you can come up with a All right, so if you can come up with a number for like a word problem, I can make like 3.25. I spent $3.25 at the store. I need to take the square root of 20 feet. That's a real number too, and it may not be pleasant, but all real numbers like 3 and a half and 0.12 repeating and the square root of 20 are all real numbers because they could exist in the real world. Integers are numbers without decimals. They can be positive, they can be negative. So integers are whole numbers that can be positive or negative. Okay, and include 0. So let me throw that positive or negative sign. Integers could be 1. They could be 215. They could be negative 44. Stuff like that. No decimals, no fractions unless that fraction simplifies to a whole number. Rationals are any number that can be written as a fraction. So rationals are any number that can be written as a fraction. So an example could be like a half. That's written as a fraction. 0.5 is a half. So that could be written as a fraction. 0.5 repeating. We'll learn how to do that in a second. Even the number 5. And if you're like, well, that's not a fraction, sir. Sure it is if I put it over 1. Gotcha. Last but not least, irrational numbers are not rational. So numbers that can't be written as a fraction. These are numbers that are decimals that go on forever. Have no pattern, can't write as a fraction. So, like, for example, I don't know what the square root of 20 is because if I took the square root of 20, I'm going to get some terrible, terrible, terrible number. So the square root of 20 is irrational. Pi is irrational. 3.14159, blah, 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 blah. 0.121221222. No, I mean, no obvious pattern, and there's no way that I can turn that into a fraction. So those are irrationals. Terrible numbers that go on forever that have no pattern. Now let's talk about repeating decimals. Repeating decimals like, 3.67 repeating are usually over numbers like 9, 99, or 999. And if you're like, well, which one is it? 999, 999, etc. Which one is it? Well, let's find out. The amount of repeating numbers that I have is going to be the amount of numbers, the amount of 9s that our number is going to go over. So, for example, 0.45 repeating is 2 digits. So, now I'm going to put the big 3 there because it's there. 0.45 repeating is 2 digits. So I'm going to put 45 over 99. Now, here's what you have to remember. You have to look at that and say, can I simplify that any further? Sure, I can. 45 and 99 are both divisible by 9. So this becomes 3 and 5/11ths. But the key thing is however many numbers repeat, that's how many 9s you put it over. So 458 is 3 numbers repeating. 4, 5, 8. So I'm going to put that over 1, 2, 3 9s. I can't simplify that. 847 is repeating. So that's going to go 847. That looks terrible. 847 is going to go over 3 9s. No number goes in front of it. Only 1 is repeating, so you're going to put it only over 1 9. And let's put that big 5 in front of it. 0.89 is repeating, so 8 9 over 9 9. That doesn't simplify. Put that big -8 in front of it. 0.72 is repeating. So I can say 72 over 9 9. And then you might be thinking, wait a minute, I can divide 72 by 9. So if I divide the top and the bottom by 9, I get 8 over 11. 8 over 11. Now there's a calculator trick here. And do I have a TI-84 Plus sitting around? That's my TI-89. Let me see if I have a TI-84 Plus just lying around somewhere. I thought I did. Where is it? Where is it? I have a TI-83 Plus, which does the same thing. It's going to be the same trick. So here's the calculator trick. You ready? I have 8.176 repeating. So this is what I'm going to do. I'm going to type out 8 point, and it's 176 repeating. So I'm going to go 176, 176, 176, 176, 176, and type 176 until I get to the second row. Okay, I'm going to hit enter. And actually, don't do the whole thing. Let's just do the 176. So point. 176, 176, 176, 176, 176. I'm just putting point 176, 176, 176. I'm going to go to math. There's a math button right there. And I'm going to go to frac, which is my fraction. Hit enter, and look at that. 176 over 9, 9. Now, we knew that already. But this is going to become 8 and 176 over 999. Very interesting. Let's do it again with 12. 0.12, 12, 12, 12, 12, 12, 12, 12, 12. That's good. Math. The math button's underneath the alpha button. Frac is the first thing there. Enter. And it gives me 33. It gives me 4 over 33. And if you're wondering why, well, 12 over 99 can simplify, and it's going to simplify into 4 over 33. Don't forget the big 3 in front. All right, so let's take a look at, I think I have 15 practice problems based on a lot of this information that we can do. All right, so this problem or this page is designed to take about 20 minutes. We'll see how long it takes us, but here we go. Which set of numbers includes the square root of 20? 20 is not a perfect square. I don't know the square root of 20. So if I take the square root of a number and I don't know what that is, it's going to be a terrible number. And if it's going to be a terrible number, I only have one option, and that one option is irrational number. Okay? The square root of 20, and I'll type it in here, the square root of 20, according to Mr. Calculator here, is terrible. So there's my terrible number. It goes on forever. It has zero pattern. So that's an irrational number. Speaking of irrational numbers, problem 2, which number is an irrational number? Remember, an irrational number has no pattern. It's a decimal that goes on forever. So it can't be A because A is a fraction. It can't be B because B is an integer. Now that leaves me between C and D. Now both of these go on forever, but one of these doesn't have a pattern. So 0.1578363, I don't see a pattern there. 0.35858585, there's a pattern and it's 85. So since it has a pattern, that means it's rational. And since C doesn't have a pattern, it's irrational. Remember, rational means it can be written as a fraction, and if it's a decimal, it has a pattern. So now it's asking for the rational number. Which one of these, if I found out, is going to be rational? Well, if you don't know what these square roots are, good thing we have calculators. The square root of 8 is a terrible, 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 terrible number. So the square root of 8 is irrational. So it's not going to be U. The square root of 25, well, wait a minute. I know what the square root of 25 is. It's 5. So it's going to be B. The square root of 30 is terrible. Pi is terrible. So the square root of 25 is 5. That's the rational one. Going back to which one is irrational. Irrational means it's terrible. So the square root of 81, I know what the square root of 81 is 9. So that's not irrational. That's lovely. 9 is lovely, so it can't be U. Negative 11 is lovely, so it can't be U. The square root of 5 is terrible, and let's just double check. The square root of 5 is terrible, so it's got to be U. And 0.3 repeating can be written as a fraction. 3 over 9, which is the same as 1 over 3. So it can't be U. Which choice orders numbers from least to greatest? All right, so I have 4 numbers in each, and they're all the same numbers. So let's list them out. Okay, 2.22 repeating is the same as 2.22222. That's a 222. La 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 la. We just did the square root of 5, and that's 2.23. 2.2360667 blah 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 blah. 2 3/5 is 2.6. No calculator needed for that one. And 2 5/8. What color didn't I use here? Blue. 2 5/8, I believe, is 2.625. Yes. And look what we did. It's already in order from least to greatest. And that's what we want to do. Put it in order from least to greatest. So A is my answer. By the way, if you're wondering, how did he do 3/5? How did he do that in the calculator? How did he do 5/8? 5 divided by 8. Okay, and that gives you this 0.625. So how about that? It was already in order. Nice. Ah, so much easier. Between which whole numbers is the square root of 456? Well, let's find out what the square root of 456 is. 21.3. So if you're thinking money, $21.35 is in between $21 and $22. So this one is going to be, since that is 21.354, blah, 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 that's going to be in between 21 and the Taylor Swift special, 22. Which square root is marked as a point on this number line? All right, so let's see what all of these are. The square root of negative, I can't take the square root of a negative, so you're not even as an option. Square root of negative is impossible. Square root of a negative number is impossible. The square root of 0.5 is 0.7. 0.70. So we'll put 0.71 because it rounds that way. The square root of 2.5 is 1.58. So 1.58. And the square root of 5, I feel like we did this a bunch of times, is 2.236. So we'll do 2.24 because it rounds up. All right, so let's see if this guy, 0.71, is seen somewhere on this number line. 0.71 would live like right around there. That dot is 0.5. So 0.71 is not on the number line, so it's going to be not you. The square root of 2.1 is 1.58. So 1.58 would be somewhere around here, and there's no dot there at all, so it can't be you. And 2.26 will be a little after 2 and definitely before 2.5, so it's going to be that one. Great. Now I'm going to do 8 without a calculator because I have the first 15 square roots memorized. Okay, the first 15 square roots are called the perfect squares. So let me quick go up here and write out the first 15 perfect squares. Okay, I have a little bit of space. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared, is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And 15 squared is 225. So if I wanted to say, like, what's the square root of 64? That's a nice number. That's 8. What's the square root of 81? That's a nice number. It's 9. So the square root of, like, 70 would live in between 8 and 9. What's the square root of 121? It's 11. What's the square root of 144? It's 12. So the square root of 130, which is in between 121 and 144, is going to be in between 11 and 12. So let's go back to this guy. I don't know what the square root of 175 is. So I'll just write it out here. I don't know what the square root of 175 is. But what I do know is the square root of 169. That's 13. And I know what the square root of 196 is. That's 14. So if 169 becomes 13, and 196 becomes 14, and 175 is in between these two, then the square root of 175 is going to be in between those two. So let's take a look at 19, or 9. I don't know what the square root of a 227 is, but you know what I do know? The square root of 225 is 15. So the square root of 227 is going to be a teensy bit more than 15. So 15.0 something. So in between what two whole numbers is the square root of a 27? 227? It's going to be in between 15 and 16 because $15 and like 7 cents is going to be in between $15 and $16. 7 over 2 is 3.5. What number of these is greater than 3.5? Not pi, because pi is 3.1, not 3.44444. So let's find out what these two are. The cube root of 27, I already know what it is, but let me remind you how to do it in a calculator. To do a cube root in the calculator, you're going to go to Math underneath the alpha button, and you're going to find the cube root. Oh, whoops, I have to turn it on first. The cube root is going to be 4. Okay, the cube root is going to be 4. So the cube root of 27 is going to be 3, which makes sense because 3 times 3 times 3 is 27. So is 3 greater than 3.5? No. So it's not going to be U. So let's just double check. The square root of 13, second button, x squared, second button, x squared, 13 is going to be 3.6 and then some. So it's B. Which symbol makes that number sentence true? Those of you who forgot, if it points to the left, it's less than. If it points to the right, it's greater than. And if you attach a little line underneath, it's less than or equal. So pi is 3.14. So 3.14 is going to be bigger than the square root of 4, which is 2. So 3.14 is going to be greater than 2. 3.14 is going to be greater than 2. All right. There goes my daughter trying to sell fake food downstairs. Oh, she's going to get arrested. Which answer lists the numbers found from greatest to least? We have to be careful. So we have the same numbers again. We have, and let me put it over here. We have 6 over 11. So I'm going to write out 6 divided by 11, which is 0.545454. So I'll just put 0.545454. Okay, it's repeating. Then I have 1.5105. 1.1015. I don't need to rewrite that out because that's normal. The square root of 3 is 1.732. And the cube root of 8, I already know what the cube root of 8, but just to remind you, the cubed root button is math 4. So you hit math, okay, there it is at 4, and then 8 is going to give me 2. So which of these is the greatest? The cube root of 8 is the greatest, so not U and not U. Which one's the second greatest? The square root of 3, so it's going to be C. Between what two whole numbers is the cube root of 83? Math 4 gets me the cube root button. 83 is going to be 4.38. So 4.36, sorry, not 38, 4.36 is going to be in between 4 and 5. Who's knocking at my door? they're not answering. Which whole number is closest to the square root of 355? The square root of 355, enter, is 18.8. So 18.8. Please stop knocking at my door. Who is that? What do you need, baby? I know you're probably running around in your underwear, so I can't necessarily have you on camera right now. Kids. I don't know if she's running around in her underwear, but knowing her, she's 3. She's running around in her underwear. So 18.84 is closest to 19, so that's going to be my answer. Hold on, Kelsey Belsey. Give me about 2 minutes. All right. One more. Write 0.123 as an equivalent fraction. All right, 1.3 repeating means you put it over 3 nines. Here's the thing. You have to look at this and ask yourself, can I divide this? Can I simplify this any further? And the answer is yes. I can look at the top and say, I can divide the top by 3. I can divide the bottom by 3. And by dividing the top by 3, that gives me 41 over 333. No number in front because it was 0 point stuff. So my explanation would be I have 3 numbers repeating, so I'm going to put it over 3 nines. I can simplify that fraction further. What? What? Special delivery. I'm going to special deliver you a knuckle sandwich. So anyway, 123 divided by 999 is 41 over 333. And I'm going to end the video now because my kids are annoying me. Bye. That's the end of first packet. Bye.